This is a planetary gearbox. While it may look simple, there's actually a lot of things that make it really interesting. I designed and 3D modeled the gearbox using Fusion 360. There are 4 main components in a planetary gear set. First, we have the sun gear. This is the center gear in the gearbox. The axle of the sun gear will be inserted into what's called the planet carrier, the second component. The planet carrier holds the planet gears, and the planet gears orbit around the sun gear. So far we have 3 components, the sun gear, the planet carrier, and the planet gears. The 4th component is what's called a ring gear. This is because it's shaped like a ring. When designing parts for 3D printing, it's sometimes difficult to get the tolerances right, the spacing between the different components. I'll have to go back into the CAD program and make the planet gears a little bit smaller. The way I have this gearbox set up allows me to spin each one of the gear components individually. Back in Fusion 360, you could see that I did add some space in my original design between the gears. However, the spacing is not quite big enough. What we could do is offset the outline of the gear and extrude it all the way back. That way the teeth are a little bit smaller. You can see here how there's more space between the gears. It's hard to tell the difference, but the new gears are a little bit smaller than the old planet gears. To make everything run a little bit smoother, we could use silicone oil. Now let's assemble everything and attach it to the base. I'll be using super glue to attach the handles and the top of the base. And it looks like my tube of super glue is leaking, and now I have super glue all over my fingers. It also helps to sand down any 3D printed parts before supergluing them together. Now that we have the planetary gearbox set up, let me show you what makes it so cool. So as you can see here, the sun gear can be turned with the orange handle. The planet carrier can be controlled with the blue handle. And finally, the ring gear can be controlled with the copper handle. You can see when the sun gear spins, it causes the planet gears to rotate around. And remember, the planet gears are held in place by the planet carrier. You can see the planet carrier, it's the white pegs. And that's connected to the blue handle in the back. You can see the sun gear spin when I spin the small orange handle. This causes the planet gears to roll around inside the ring gear. And finally, if we hold the sun gear steady and move the outer ring gear, this also causes the planet gears to rotate around the sun gear. Now you may notice there's a lot of different combinations and interactions between these gears. A planetary gear set actually has 6 different gear ratios built into it. So notice how there are 3 handles. Depending on which handle we hold steady, it changes the gear ratio. If we hold the ring gear steady and spin the sun gear, you can see that we have a 3-to-1 reduction. This means that we have to spin the orange handle 3 times for the blue handle to spin 1 time. And now if we spin the planet carrier, it's a 3-to-1 increase. When the blue handle spins 1 time, the orange handle spins 3 times. But what happens if we hold the planet carrier steady? Check this out. We actually get a negative 2-to-1 gear ratio, which means the ring gear is actually spinning in reverse at a 2-to-1 gear ratio. We could also do a 2-to-1 reverse increase by spinning the ring gear. That may sound complicated, but it's actually really simple. Every time you spin the copper handle, the orange handle spins the opposite direction twice. Now what happens if we hold the sun gear steady? In this case, we get a 3-to-2 gear ratio. The copper handle will spin 3 times and the blue handle will spin twice. And finally, if we hold the sun gear steady and move the planet carrier, we get a 2-to-3 gear ratio. It's hard to see, but every time the blue handle spins twice, the copper handle spins 3 times. And yes, I should have secured the planet gears better. Let's do it again from the front so you can see the interaction between all of the gears. Here's the 3-to-1 gear ratio. Let's count the rotations of the orange handle. 1 rotation, 2, and 3. And this is the 1-to-3 gear ratio. So you can see just by spinning the blue handle, the orange handle will spin 3 times. This is the 1-to-2 gear ratio. We also have the 2-to-1 gear ratio. So every time the small orange handle spins twice, the outer copper handle only spins once in the opposite direction. And this is the 3-to-2 gear ratio. You're probably getting the idea here. There are a lot of different combinations. And finally, the 2-to-3 gear ratio. And there's actually one more gear ratio that's not quite as obvious. This is a 1-to-1 gear ratio, which doesn't seem to make any sense unless you look at it in context with when these gearboxes are actually used. An automatic transmission changes what gear your car is driving in. A 1-to-1 gear ratio in a transmission is called a direct drive, where the engine is spinning exactly the same speed as the output. Because planetary gearboxes have so many different variations of gear ratios, it makes it perfect for being used in automatic transmissions. But is there a way to predict which gear ratio we get depending on which handle we spin? I'll show you how to do this in just a bit. If you want to 3D print this planetary gearbox, I'll have the files for free to download on my website. And if you want to learn how to design and 3D print this gearbox, I'm working on something really special. I'll be launching it on February 2nd, 2022. 2/2/22, really easy to remember. It's my most comprehensive program I've ever made. And if you really want to stay in the loop, go to my website and add your email. I also have a ton of free STL files that you could download on my website. I've curated some of the best STL files just for you. If you want to predict what gear ratio you get depending on what handle you spin, I made this convenient chart. This may look confusing, but let me explain. This column is the handle that you spin. And these are the gears that you hold stationary. So for example, if we spin the planet carrier but hold the sun gear steady, we could expect to get a 2-to-3 gear ratio. And here we can see exactly that. We're holding the sun gear steady and we're spinning the planet carrier. This gives us the 2-to-3 gear ratio. The gear ratios also depend on the number of teeth of the sun gear, the planet gears, and the ring gear. Using formulas to calculate the gear ratio of a planetary gearbox is a little out of the scope of this video. But I hope I was able to show you how powerful this contraption is. Thanks for watching. I really hope that you enjoyed this video and learned something new. If you want to support my channel, please consider becoming a Patreon member. And don't forget, there's a whole bunch of free files that you can download on my website. And check out my YouTube channel for more videos just like this. Thanks for watching and happy printing.